Hello everyone, I am Ayush Agarwal and I have some secrets about I mean quantum space-time I would like to share with you. Why should you bother watching this video? Let me give you some spoilers here. In this video, we will be using a dimensionless fine structure radius that exists in a three spatial dimension world, which will be used to define the length and time we measure in our world. We will be describing its interactions using thermodynamics to derive the mechanism of electromagnetism and gravitation. Lastly, we will use complex numbers and find out where the iota, the imaginary axis lies, and where the real axis exists in these three spatial dimension and our reality. How does that make sense? We will explore in this video. It follows Galilean relativity. In this world, there exists some fundamental constants. These fundamental constants include that the distance between the flagpoles is always constant everywhere, and the speed with which the wagon travels is constant due to some mechanism. This mechanism, this mystery mechanism, is what I will be explaining in this whole video. So for now, I will just wrap into a gift paper and put it here. You should treat this view more like a space-time axis, where this is the x-axis and this is just a garbage axis. Why do I call this a garbage axis? We can represent the same graph in this manner and no information is lost. We can represent the whole scenario that I explained in this graph and nothing is changed. The only thing important here is the x-axis, and you should treat that x-axis as the God truth. No one else is seeing that truth, not even the guy in the world. You are the one that is seeing the truth, not even me. So let me give you an example about the mystery mechanism I was telling you about. You see the YouTube full screen minimize button right there? Try clicking on it. I would like to ask you what changed. Nothing? Try clicking it again. Still nothing? Look closely. What I said to you is you are observing the truth. No one else is. So, by that definition, when you were in full screen, that guy was moving at 10 pixels per second. Let's say when you minimized it, it started moving at 5 pixels per YouTube frame. But YouTube frame and pixels, those unit doesn't make sense in this universe. That is true. For this guy, the only units that make sense is uh, flagpole distances and wagon times because those are the units in his universe. But still, for some reason, I will classify that YouTube button as an external factor to this universe. Now, leave that YouTube button aside. Let me do some internal factors that will demonstrate the true capabilities of this mystery mechanism. Now, let's say his universe is contracting. Due to the mystery mechanism, the wagon will slow down to match its one flagpole distance per wagon time thing. So this guy will experience a pseudo force. We can clearly see As the wagon is decelerating due to the mystery mechanism, the guy will experience a pseudo force due to his inertia, throwing him in front of the wagon at all times. Let's see an opposite scenario of this. The world is expanding. So, what will happen? The wagon will start accelerating, and due to its acceleration, the guy will experience a pseudo force to the back of the vehicle. Here, the mystery mechanism is accelerating the wagon, and the guy trying to be inertial experiences a pseudo force in this opposite direction.
No one has measured the speed of light? That's ridiculous. The speed of light is exactly 299,792,458 meters per second. We are so sure of it that since 1983 we've actually used the speed of light to define how long a meter is. It's just the distance light travels in a vacuum in 1 over 299,792,458 of a second. That definition ensures that the speed of light is exactly this number, no decimals. But hear me out. In this video, I will prove to you that light may never actually travel at this speed. And I can say that because no one has actually measured it. We can't measure the speed of light the same way we measure the speed of anything else. Imagine you have a laser that can fire a beam through a perfect vacuum for 1 kilometer. Start a timer the instant you fire the laser beam, and then exactly when it hits the end, stop the clock. Except, how do you know when light reaches 1 kilometer if you and the clock are at the starting point? Okay, so you need 2 clocks, one at the laser and one at the end, which stops automatically when it detects the laser light. But now, how do you make sure your 2 clocks are synchronized? Well, you could connect them via a wire and send a pulse from one to the other, but that pulse will travel at the speed of light, so it will arrive with a time delay. You might think you can just subtract that time delay, but it is equal to the time it takes for light to travel 1 kilometer. That's what we don't know and are trying to measure. Okay, new plan. Start with the clocks together and sync them up first, and then send one of the clocks down to the end. Now, what could possibly go wrong? Well, I'll tell you. The clock at the finish line was moving with respect to the one at the start, and special relativity tells us moving clocks tick slow relative to stationary observers. So by the time the clock reaches 1 kilometer, it will no longer be in sync with the clock at the start. Can I tell you the only solution to this problem? Ditch the second clock. Put a mirror at the end to reflect the light back, and use a single clock at the start to time the full 2-kilometer round trip.
Michael from Vsauce created a wonderful ruler, which I will actually treat as an artifact. This ruler has length in light picoseconds all the way up to light nanoseconds. This ruler is 29.97 and so on centimeters long instead of regular 30 centimeters. I can do a really simple scattering experiment with our eyes. I place my eye on the 0 second mark and place a pencil on the 1 light nanosecond mark. As soon as I open my eye, a photon hits. I'm talking about the moment the photon hits my eye. The retina hasn't absorbed it, my brain hasn't processed it, nothing happened. I'm talking about the moment the photon hits my lens, eye lens. At that instant of time, I'm asking, where is the pencil? You see, the photon has traveled presumably 29.97 centimeters, and it took presumably 1 nanosecond. So that information the photon gave me is 1 nanosecond old. It is not present. It is 1 nanosecond in the past. And that too presumably. I will explain the presumable part later. But That doesn't give the information where is it right now. If the pencil is not moving, we can say the distance was 29.97 centimeters. That hasn't changed. But if the pencil existed in an accelerated reference frame, the length that photon shows it is not correct. The pencil has already moved away. It shows you the information of the past. It is not what is happening right now. You don't know the position of the pencil right now. So we are completely blind to it. We can't see anything from the present. The only information we get is from the past. But the thing is, our length can change and our time can change. That is in the special relativity. Speed of light is constant, but length can change and time can change. Time can dilate and length can contract. So how can you say the length that, let's say, the 30 centimeters you measure at today 2 p.m. will be the same as the 30 centimeters you measure at 3 p.m. You can't. You are not using the same photon. You can't say that. And even you can't say that the seconds ticking at 2 p.m. and the seconds ticking at 3 p.m. are the same. You can't say that. This is the same as our trolley example. That guy will always measure two flag distances upon two wagon times. Always. He will always measure the two-way speed of wagon constant, no matter if the universe is contracting, expanding, or is same. And if we are in accelerated reference frame, we can't say that our length across time and even our time across time are constant. We cannot say that. The two things that are dimensionless and we can define are position, and only the position we can define is the origin 000. That is dimensionless. You don't need any units to represent that. And the only time you can represent, which is the only instant similar to position, there is instant. The time is synonymous to length. You see the connection? So the position, which is dimensionless, is the origin 000, and the time, which is dimensionless, is right now. Everything is frozen. No information is transferred. You can't observe it, but that kind of reference frame in which you were able to see everything, you were calculating everything, all of the pseudo forces were known in that reference frame, the length and time differs. That light is a wave in space. From the Thomas Young's uh, double slit experiment that was done in 1801, we can clearly see the interference pattern that is in space. The waves from different spaces interferes to create the pattern. Here, the two inter these waves from two different positions interfere with each other to create the pattern. And light is also a wave in time. To explain this, I will use a YouTube video from Astrom that describes a research paper from 2023.
They took a transparent material called indium tin oxide that, under specific conditions, can be made to be reflective. Indium tin oxide is the stuff they use in most mobile phone screens. They fired a laser at it, and then rapidly changed the material from transparent to reflective and then back again. This left only a slim window, a few femtoseconds, where the laser was reflected. They called this a time slit. They recorded what the laser looked like after it had been reflected, and found that its frequency had spread out a little bit in the process, but other than that, nothing too crazy had happened. The weird thing was what happened when they sent two laser pulses through these time slits in rapid succession. The position of the emitter, the mirror, and the receiver remained the same. The only thing different was the time the lasers went through. Oddly enough, when two went through, an interference pattern happened. This was not an interference pattern in the same sense as with the regular 3D space double slit experiment though. This was an interference pattern that had affected the laser's frequency. Certain frequencies of light within the laser faded out, exactly in line with the way intensity faded out in the regular version of the double slit experiment. To visualize why this might be happening, let's draw out this experiment in regards to time. The time slit experiment can be drawn in a similar way to the double slit experiment, except we are going to need to visualize the change in the experiment over time. To do that, let's create a 4D graph where space is along the x-axis and time is along the y-axis. This is easy enough to do, it just looks like this. The photon leaves the emitter to the left, hits the time slit, is reflected, and arrives at the receiver. I've drawn this as a continuous line just to make things simpler later, but the idea works just as well either way. Later, a second photon is released from the emitter. It reflects and arrives at the receiver at a slightly later time, represented in how it takes place higher up, further into the future on our time graph. If light behaved normally, traveling along at the speed it was supposed to go at, this would be the end of it. Instead, light is interfering with itself. This means it must be traveling along a path that takes it through the other slit as well as its own. This is the only way that light could come in with the pattern that we see. And just like in the double slit experiment, it's likely happening on the other side of the slits too. As for why it's frequency and not intensity that's being messed with here, think about the implications of what you might see if light did indeed come in at a different angle like this. Photons come in little packets of waves, as I've previously mentioned. Now look at what happens if you change the angle at which those waves arrive. Here's how it normally might look. I've added a black timeline here and have highlighted every time the receiver receives a new peak in the wave. Here's what happens when you alter the direction of the wave's arrival. Suddenly, the peaks are coming in much more frequently. The frequency of a wave over time is very much connected to the color we perceive light to be. Lower frequency light is redder in color. Increasing the frequency shifts light's color towards blue. So this color variation makes sense. What makes less sense is what's going on with the paths this light is taking through time. Remember, the straight lines we started with represent the 299,792,458 meters per second that we see light traveling. So what can we say about the photons that are traveling along these paths? For some parts of their journey, they are traveling slower than the speed of light, taking more time to arrive at a destination that's the same distance away, and yet, for other parts of their journey, they are traveling faster than causality ought to allow. From their perspective, they are traveling backwards in time. As a reminder, these two emitters on the left are actually the same one, just at different points in time. The same for the receivers on the right. It is a mind-bending result. And yet, according to the results of this experiment performed by a research team at the Imperial College in London, this is what is occurring.
From this experiment, we can clearly see that light from different times are interfering with each other, creating an interference pattern in time, in frequency. So, light is a wave in space and time. electromagnetism is just spacetimeism? Well, let's just keep this in mind for now.
First things first, what is dark energy? Dark energy is what causes the expansion of the universe to accelerate. It's not only that astrophysicists think the universe expands, but that the expansion is actually getting faster. And here's the important thing, matter alone cannot do that. If there was only matter in the universe, the expansion would slow down. To make the expansion of the universe accelerate, it takes negative pressure, and neither normal matter nor dark matter has negative pressure, but dark energy has it. We do not actually know that dark energy is really made of anything, so interpreting the pressure in the normal way, as by particles bumping into each other, may be misleading. This negative pressure is really just something that we write down mathematically, and that fits to the observations. It is similarly misleading to call dark energy dark, because dark suggests that it swallows light, like, say, black holes do. But neither dark matter nor dark energy is actually dark in this sense. Instead, light just passes through them, so they are really transparent and not dark.
So, due to dark energy, our universe is expanding and is accelerating. We would see its graph going like this, where this is the speed of speed of expansion, and this is distance of galaxies. But I have explained to you that whatever we see is in the past, not in the present. So, the conclusion we draw from here that the as we go farther away from us, the universe is expanding faster is incorrect. The correct conclusion is as we go farther into the past, universe were expanding faster and it is gradually slowing down. So the actual graph would be speed versus time. Here I would start the zero with the Big Bang. So some of the information is obviously unknown. And after that, the universe is going like this, which will also correspond to the recent speculations about dark energy decreasing. And if we continue on that pathway, it will be going like for this dark energy uh, decreasing correction, we will need another darker dark energy, and that darker dark energy will again be increasing. The jerk will not be constant, it will be increasing, and then that will be decreasing, and so on. We will need infinite corrections in this model to get back to this model. So the dark energy is not real. It is just an illusion because we are trying to evaluate it at present, but the things are about the past. With this graph, we also see the universe is like diffusing, like gases. If it is expanding, there needs to be some kind of restriction that is sapping its energy away. So to make it behave like diffusing. Otherwise, the universe will expand constantly, like it is exploding. So there is some kind of restrictive force that is putting pressure on the expansion. So the expansion is decreasing, and that pressure is due to dark matter.
Let's start with a photon in a gravitational field. There is this famous experiment conducted in 1959 by Pound and Rebka, sending photons up and down a 22-meter tower at Harvard. Now they used gamma rays, but I'll represent them with visible light. They found that photons detected at the top of the tower were redshifted relative to the source by the exact amount predicted by general relativity, which is a tiny amount. I'm dramatically exaggerating the effect just so you can see it. Now, where along the photon's path does this redshift take place? Well, it seems to happen continuously. The photon loses a little bit of energy each millimeter it climbs up that tower, meaning that the photon in the middle of the tower would appear green. Now, according to Einstein's equivalence principle, being at rest on Earth's surface is indistinguishable from being in a rocket in deep space accelerating up at 1g. So, we could do the same experiment in a rocket ship and we should get the same result. If we send blue photons from the back of the rocket, they should be red when they reach the front. And in the middle of the ship, they would appear green. This is exactly what we saw at rest in a gravitational field, so the equivalence principle holds. Now imagine there are a line of external observers just hanging out in space at rest relative to each other, and they can all see into the rocket. Let's also say the rocket is initially at rest, and the thrusters are switched on the instant the photon is released. Now, since both observers are at rest at this moment, they will both measure the photon as having the exact same wavelength. It's blue. But what about when the photon reaches the middle of the rocket? Well, we know someone inside will see it as green. But what about a stationary observer outside? Well, to them, the photon has just been moving through ordinary flat spacetime, so it must look blue, just as blue as it was when it was emitted. So what's the deal? How can the same photon look green and blue at the same time? Has the equivalence principle been violated? The answer is no. It matters a lot to this measurement who is doing the observation. Consider this. After the photon is emitted, the rocket accelerates. It's speeding up. So by the time the photon reaches the middle of the rocket, everyone inside is now moving at high velocity relative to the source when the light was emitted, and relative to the observers outside the rocket. So it makes sense that the photon as measured inside will look different. It'll be redshifted. This is the Doppler redshift because the observer in the middle of the ship is moving very quickly away from the source. By the time the photon makes it to the top of the rocket, well, the rocket will be going even faster, and this is why it appears red. But to a stationary observer outside, well, it still looks blue. This thought experiment misconception is to think that because photons are redshifted as they travel across the universe, that means expanding space is pulling on things and stretching things apart. That's not how it works. Space is not like that. So let's come back to the central question of this video, which is, do you expand with the universe? The answer is no, because on the scale of people, the universe is not homogeneous. I mean, matter is condensed down into objects and the Earth. And the universe is not isotropic. Looking up looks decidedly different from looking down. The basic assumptions we made about our expanding universe just don't apply here. I mean, the local space-time curvature is dominated by the Earth.
I came across a expanding Earth debunking video. I'm not here to defend the original theory, but I think we can get a few key takeaways from the debunking video. So basically, I am sniffing gold in the garbage here.
Spread of the Pacific. He says it's too difficult to easily visualize because of how big it is. To that, I would say, is it that, or is it too hard to easily visualize Because it didn't happen. Every time he shows a map of the planet expanding, he conveniently happens to like gloss over the Pacific at the most interesting times, kind of showing how everything really fits together. He definitely touches on it, but I think it's really funny because like everyone knows that in the Atlantic the continents were joined. You can fucking see that on a map. It's like puzzle pieces. But the thing you need to back up the most to make this theory make even a lick of fucking sense is how it worked in the Pacific, and he just doesn't do it.
Point. And let's look at the area in question, which is basically the Pacific Ring of Fire. Here, these areas are in a trench, and these areas are ridges. So we can say that the plate is, if the Earth is something like this here, this is the northern side, this is the southern side. So there is a depression kind of thing here, and on the other side there is a ridge like this. So the this is on this direction, so the arrow is this. But we can also see that right here is a ridge and then a plate going here back. The plate became a ridge and then a small plate goes back to, this is the south side. So the plate have uh, are pushing in this direction, and it's looking like there was a collision right here, and it has pushed this stuff here, creating a chip of continental plate, the Nazca plate right here, going rising in this direction, but it is also being pushed in this direction here, creating a arrow of volcanic activity here. And this whole region is Earth's most volcanic area. With all of these conclusions in mind, can't we say that this ring area is actually the crater that created?
Pause for effect.
So with this, I would like to propose the celestial body that impacted the Earth at Pacific Ocean, created the moon and broke the continents apart and started the tectonic plate activity. With this, I would like to suggest the expanding Earth pushes the space outside it away, that is the dark matter, and as it pushes the dark matter away, the dark matter makes a reaction pressure force that we experience as gravitation. After a certain distance away, there will be a region where the expansion of the Earth and the expansion of the dark matter will oppose all of the dark matter above here. So if we take a cross section, at this point, the Earth is expanding, the dark matter here is expanding, and the space behind you is expanding. So you will not move anywhere. You will not experience any gravitational force. Beyond this point, you will start experience force in this direction, opposite from the massive body. So you will be like galaxies going apart from each other. You will experience the expansion of the universe. So let's go back to the ether theory, which was disproved by Michelson-Morley experiment. The original ether theory had few assumptions: that ether fills all the space around us, ether is at absolute rest, and matter does not interact with ether. But Michelson-Morley disproved these assumptions. So I propose an alternate assumptions which will satisfy all of the original luminiferous ether demands and is consistent with Michelson-Morley experiment. So first, ether is everywhere. Second, ether is perfectly dynamic like a ideal gas, but it's not really an ideal gas. I will explain that later. And last, we are all made up of particles of ether, so we cannot distinguish any interactions like neutral cradle. So suppose if we are talking about neutral cradle, this ball hits this one and the system becomes like this. Here, if we imagine these to be the ether particles, so the ether that is moving here strikes this one and becomes part of your rest body, and the particles simply flew away. You you don't even experience that. That is why this is the third postulate: we cannot distinguish any interaction. Now I reveal my trap card. In this reference frame, we don't have anything, and only things we can define here doesn't make sense in our universe. Like our original example, that was basically a Laplace Demon reference frame in disguise. You measure things in pixels per YouTube frame, but those units don't make sense in our world. That is this reference frame. So we can only define dimensionless quantities that correspond to our own physical reality. So let's look at what dimensional quantities we have. The first one is position. We can easily define our position 0, 0, 0. And the next one is right now, the instant of time, t equal to 0. That is what we can define. So those two are unitless, dimensionless quantities, and we can define them here. Now, we need to define the particles of ether, and then we have to define its interactions using thermodynamics. So basically Newton's law of motion. But what the choices we have for the particles? So let's take up example for a point particle. If we assume it to be a point particle, then the probability of their collision is almost zero. If you zoom in far enough, these two particles, although they look like they will collide, but zooming this scenario far enough, you will see these particles barely miss each other. And so this universe will not function. The next thing about point particle is we define the interactions something like two particles coming and colliding like this. But if we go to a particle's reference frame here and face to the direction of collision, so this is our point size particle, and the incoming particle is from this direction. So this collides and goes this way. And there are other collisions that could go this way, this way, this way, this way. But we see the problem here. There is no way to differentiate between these collisions with the point particle. So we cannot have a point particle. If we imagine this scenario, what was the difference when I expanded the universe and when you use the YouTube full screen button to expand or contract the universe? What was the difference? Why can I say that the YouTube full screen button is an external factor and this expansion is an internal factor? Or more specifically, what was unchanged in this scenario and what changed in that scenario? You should more like use the scenario this one. So this is the constant one. You can use the full screen button to check out, and then I will start expanding the universe. So my question is, what is the difference between those two scenarios? Well, I'm classifying the YouTube full screen button as an external factor. That means there is something changing in that scenario. And this one is an internal factor. So there is something that is unchanged, that is constant throughout the whole animation, which is making it an internal factor. What is that? If you figured it out, you are a genius. It took me 3 months to figure it out. The answer is the width of the flagpole. Literally. This means so we cannot use a point size particle because it does not have the flagpole width. So what is our next solution? To use a particle of finite volume. With this, we will get a dimensionless fine structure constant, that is radius. And in this universe, that will be our standard unit of length. There is nothing else to measure length. So we will get a dimensional constant radius, which I will represent by Hindi letter R. With this, we will define, because it is a gas, it exists everywhere. The universe has translation symmetry. Because this particle is a perfect sphere, our universe has rotational symmetry. But because this particle has finite volume, our universe does not have scaling symmetry. We will observe pseudo forces when our universe kind of scales. So I will be the crazy guy here and hypothesize the Newton's law of motion. So basically, let's say Newton had a cow. He found it on a street one day walking, and Newton asked it to stop. The cow didn't stop. Newton pushed the cow and the cow stopped. And thus he formulated the first law. An object at rest remains at rest, and an object in motion remains in motion at constant speed and in straight line unless acted by an unbalanced force. Next, the Newton kicked the cow. The cow yelled "Ma," and he formulated the second law. The acceleration of an object depends on the mass of the object and the amount of force applied. Now, the Newton kicked the cow again, and cow kicked back, and he formulated the third law. Whenever an object exerts a force on another object, the second object exerts equal and opposite on force on the first. Wait a second, where did this come from? Let's talk about the cow in the room. So, mass. Mass, to be consistent with Newton's law of motion, it should define inertia. So, the dimension of mass is equal to, first, the quantity of the particle. So, let's say I enclose a sphere in which there are number of particles, these particles. So how many particles are in there, that is their first dimension. So it would be quantity, and right now we are just defining it for the one particle, so quantity would be 1 times inertia. These particles will undergo perfectly elastic collision, so their inertia by definition is 1. And lastly, we should not forget Archimedes' Eureka, that mass is related with volume. We can clearly see that mass upon volume equal to density. So density rho equal to mass upon volume. This density I would actually like to represent with packaging density. which which will be a dimensionless quantity and will match our equations perfectly well, because higher the packaging density, the more the number of collisions, the lower the packaging density, the lower the number of collisions. So mass needs to have a component of volume within them as well. So the last thing that will multiply here is volume. So dimension m equal to quantity 1 times inertia 1 times volume 4 by 3 pi r cube. This is the definition of mass we will be using in these equations. So now let's define the interactions of this particle. So let's take interactions in one dimension. let's have an array of particles in a single line, and only one of these all of these particles are at rest, and only one of them has velocity, some velocity. So what will happen? This particle will collide with this one, and this particle will basically take its place here, and this particle will start going at velocity v until it hits this particle, and then this particle will start going at velocity v until it hits this particle, then this particle will start going at velocity v, and so on. But if we talk about the particle, well, there is nothing interesting happening with that after the first collision. So every particle is identical. You cannot observe what is happening with them. The only interesting thing that happens is the velocity, and that kind of looks like superimpose it with each other. So the only useful thing, the only useful information is the velocity. Now let's take it to two dimensions. But before we take it to two dimensions, I will also have to talk about time. What is time? For one dimension, that didn't matter that much, so I was ignoring it. But now, time is something we cannot measure in this realm. We can only see the particles colliding. That's all. There is nothing else we can observe. So there is no measurement of time in here. What our real universe does is measure the distance between any two successive collisions exactly as Planck length, and time taken between any two successive collisions is exactly Planck time. So if there are two particles that are colliding, so this distance, so this particle collided here with some particle, then this particle moved all the way here, and then it collided with another particle again. So this distance from this point to this point, or from its center to its center, is exactly Planck's length, and time taken between any two successive collision is exactly Planck's time. Thus, our speed of light is constant. But there is no reason for the particle, the actual distance between the particle to be Planck length, or the time between any two collision to be Planck time. There is no reason for that. That is just our illusion. With that out of way, let's look at the two-dimensional collisions. In two dimensions, the particles will collide something like this, and can have velocities in, let's say, one has this velocity in this direction, other has velocity in this direction, and they collided with right here. You see that each of the particle has – each of the particle has sorry, this one is wrong. So if we make a collision in 2 dimensions, one has the velocity in this direction and another one has a velocity in this direction. This will be the velocity's perpendicular component and this would be the parallel component along the direction of collision. So of course these velocities can be different. Of that is not necessary they need to be same, but we measure them to be the same. They are for us normalized. The speed of light is constant, so we measure pseudo forces. But for now, we are ignoring pseudo forces and these are not normalized. So we see that the velocity is split into 2 components. The component for Vi cos theta, where theta is this angle, and this is the perpendicular component Vi sin theta. Instead of using sin theta and cos theta, can't we use the imaginary numbers? Of course we can. And our equations use the imaginary numbers. This is the reason for the imaginary numbers. So the imaginary numbers try to evaluate the speed of light as constant, the normalized value of the imaginary number. But their perpendicular component, that is the Vi sin theta, right here, this is not transferred to the other particle. Only the cos theta components are exchanged. So this kind of acts like a potential energy, but it is still a kinetic energy. Nature has no pockets to store energy and keep it. The energy needs to, the velocity needs to be in some direction. There needs to be a proper movement for it. There is no storage of energy at this scale. So if we look at the first part of the collision, I mean the first part, only one particle of the collision, and let's align the collision to the x-axis and also imagine uh, the perpendicular component is always in the y direction for now. So this is, so our velocity is something like this. This is the y, this is the x, this is our velocity. The, now we can write the velocity as a complex number. So this will be imaginary component of the v and this will be the real component of v. This real component of the v is exchanged during the collision and the imaginary one is the perpendicular. But where could be the imaginary one? In two-dimensional cases, it could be in this direction or in this direction. Let's look at the 3D case now. So we still consider, for now we consider the collision to be occur in the x direction and the perpendicular component is in z direction. So we have our coordinate axis is like this. This is our x, this is y, this is z. So our particle has the perpendicular component like this, and the parallel component like this, and the actual velocity vector like this. So what will this imaginary component do to this particle? If we look at a planar view of this, something like this is the x, this is the z, then the particle will go on. After this collision, it will go to this direction, then it will collide to this direction, and then collide, 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 and so on. And we can clearly see the perpendicular component everywhere is pointing to the center of this circle. Now, this now we take minor deviations in from z to y direction. So this imaginary component, we were saying it was in this plane until now. Now it can move a bit here and a bit here. The imaginary velocities will be in this direction, and I would suggest those angles to be pi by 4, because after this we can just consider these to be in the direction, y major direction, then to be in anti-z direction, I mean negative z direction, then to be in negative y direction. So with that, what will happen is these particles would, let's say, these are the collision happening, and this is one plane. So there will be another layer above it, and now as the velocity have a component in y direction as well, they will disturb the particles in their upper layer to also resonate in the same direction. So it would create kind of cylinders going like this. And taking the right hand thumb rule with clockwise direction as down, this is our lovely magnetic field lines. We got them here. And for the electric field lines, let's look at the Faraday tensor for a second. In the Faraday tensor, we can clearly see that the time, the dimension of time, which is ct in terms of length, And these x dimensions, x, y, and z dimensions, all are a number divided by c. That means these lengths are converted to time dimensions. So this is rate of change of time per unit length. So that means, as I said, the distance between any two collisions, it is what we measure as Planck's length. But because of a component of velocity in a different direction, the real component was a bit less than 1. So it it was slower to collide with the particle. So to travel the same length, that is for our equations the Planck length, it took more time. That means there is a time dilation going on with that particle. That is what this electric field says. Back to the conclusion. Luminiferous ether is back, now with a particle. I will be trying to get all of the probability equations, so how all of these particles are colliding over time, and I think that will take me few years. Um, I I will try to develop a software. Being a software developer, I will try to design a renderer that will simulate the particle collisions, and based on that, I will try to derive the equations that will result in the theory of everything. So all of these particles which I derived in this video, what are these? These particles I described until now to say they make up everything in our universe. Leptons, quark, bosons would be just underselling them. These particles are actually the ones whose name was stolen by atom. I will name these particles as carriers of velocity, carriers of all interaction, carriers of temperature, carriers of causality, carriers of information and knowledge for everything in this universe. In short, Gyan carriers, the Gyans. With this, I will Happy New Year out of here. Thanks for watching.